we're continuing with our questions. It's a Cambridge paper. Again, this will be very informative for those who are writing ZIMSEC exams. Cambridge is not very different from ZIMSEC, so that's a very useful point to start with. So what we're going to do is we're not only going to tell you what will be happening in the question, but we'll also discuss some of the concepts that surround the question and also justifying whatever working we'll be using. Okay, so the more that you know about a question, the more you can understand it more intuitively, such that when you have another question asked, it's kind of similar conceptually, then you'll be able to tackle it. So this one, you'll be just comparing the sizes. So let's check also what other questions that we'll be covering. So this one is on symmetry. Okay, so we'll be discussing some concepts on symmetry here, and then this next one is it's on rotational symmetry. So this question might appear as if it's vastly different from what you do in ZIMSEC, but then it's actually very, very similar, and it will be very informative. Okay, the way that they actually ask some of these questions in Cambridge, it can set you up for an enhanced sense of understanding for the questions that you actually get in ZIMSEC, which are very, very simple. I will discuss with you those questions very soon, because they tend to ask these questions in only one format for ZIMSEC. Okay, so if we have time, then we are going to do this one as well. It's arithmetic, so you'll be dealing with time. For minutes, it'd be in base 60, so that would be like really, really important. So let's start our questions. Okay, so we're starting with question 3. It says write these numbers in order of size, starting with the smallest. So if you want to compare any numbers in maths, then you actually have to have the same denominator for them. Okay, so that's the simplest one. And if you have a calculator, this one will be paper one, so you're not allowed to use any. But then if you had a calculator, then you just convert these ones to decimals, and then you just list them, and then decimals you're able to compare them very, very easily. Okay, so here we have 1 over 3. 1 over 3 is 0.33 going forward. Okay, so 1 over 3 means 3 into 1 is 0, then you have to add a 0 here. Then 3 into 10 it's actually 3, then you have to add a 1 here, which is a remainder. Then you'd have to go on. Okay, so the 1 over 3 you should know at least that it's 0.33. So we have 0.33, which we can compare to this, This is very encouraging, and we can convert this one as a decimal as well. So 15 over 40 would be, if we divide 15 by 5, then we'd actually get 3 here. If we divide this by 5 as well, then we get 8. So 8 into 3, then you get 0. Then you can put a 0 to the remainder, and then you say 8 into 30, then you get 3 up to 24. So we'd have 60 as a remainder. Then 8 into 60, then you'd have up to 56, that's 7, and then you'd have remainder 4. Then 8 into 40, then you get 5 here. Okay, so this is 0.375. Another tip that you need to know for ZIMSEC is that you can actually include all your working if you use any rough paper, then attach them at the end. Okay, so that if you are on the verge of any grade, let's say you are on 69, and then they're saying 70 is the grade for A, they can actually look for marks here. Okay, so always attach your rough working in some of these questions. And then 9 over 31, you can do the same. So 31 into 9 would be 0. Then you'd have to try for 90. So 31 into 90, then you'd have up to 62. So you'd have 2 here, so up to 62. Then you'd have 90 minus 62 here. Then you'd have 10 minus, then you'd have 8, and then you'd have 7 here. Then you'd have 28 going forward. Okay, so you'd have to try again 280 divided by 31. But then what I want to tell you here is that it's very unnecessary, because you actually know that whatever number is going to come here, it will be smaller than all the other numbers here. Okay, so your intuition, sometimes, especially if it's 1 mark, sometimes you have to be really smart about it. There's almost always a shorter way of going about these things. Okay, so if you're asked to write the numbers in order of size, starting with the smallest, then you have to write them in the way that they are written. Okay, so this was just useful for us to compare these numbers as if they were all decimal numbers. So this one you actually identify, this is 0.2 something, so this one must be the smallest. So you'd have to say 9/31 is coming first, and then all of these ones, this one should be coming next since it's just 0.3, and this one should be coming next since it's 0.33, and then this one will be coming last since it's 0.375. Okay, so I was about to make a mistake here. Okay, so don't include the numbers that you used for working out. Okay, these numbers, you have to include the actual numbers themselves. So you'd have 15 over 40 here, and then here you'd be using 1 over. So we said 0.3, then 0.32 here. Okay, so this one will be coming last. This one is the largest. So this is how you'd write it. Okay, and the other thing that you should know is when comparing negative numbers and positive numbers, negative numbers, they're always smaller than positive numbers in all cases. Okay, so but then if the size of the negative number seems to be very large, so for example -1000, it seems to be very large in terms of the size but not in terms of the sign. This one is actually a very small number when compared to, say, negative 10. Okay, so this one is more closer to 0. That means it's more positive. That's another thing that you should bear in mind when comparing the negative and positive numbers. But we're not going to dwell much on this. We're going to see if we can answer at least one more question from the next slide. Okay, so this one asks us, so it says the diagram shows part of a shape which is symmetrical about the line L. Okay, so this is the line L. Complete the shape. So the shape is symmetrical. So if it's symmetrical around line L, then you can actually identify what will be happening here. So for example, this one is going in this direction, so its reflection simply means as if line L were a mirror. So its reflection will be actually coming to the spot here. Okay, since this one is coming to the spot, this one will be coming to the spot here. And as you can see, this one is dropping down through this 2 here. So this one will also be dropping down through 2 as well. Okay, so 2 going this direction, so it would actually be here. Another way to go about it is to realize that this point, if you reflect it, it would come to this point. This point, if you reflect it, it would come to the same point. This point, if you reflect it, it would come to this point here. This point, if you reflect it, it would come it would come to that point. So at the end of the day, what you'll be having is, let me just so yeah, this is it. This would be the line of symmetry, and then this one would be the other part of the shape. Okay, such that the line of symmetry would be this line here. Okay, such that as if you put a mirror on this line, you'll be able to see the other side and also the other side. So this is it. You map according to the points. Okay, so this point was here. You just see if it bounces, it comes to this point here. And then the reflection and the reflection, and this one also same thing, and this one also same thing. Okay, so that's how we go about it. Let's move over to the next question. The next question is really tricky. So it talks about this concept of rotational symmetry. So you see most of these questions in ZIMSEC, they'll ask them in one simple way. So they'll ask you the rotational symmetry of a regular polygon. Regular polygon simply means any shape that is typically more than 4 sides. It simply means many sides. But usually when it's a 4-sided shape, we're very specific. When it's a 5-sided shape, that's when we start saying, this is a pentagon and all that. So those that end with this suffix, they're the ones that we usually refer to as our regular polygons. So if you have a regular heptagon, for example, so hepta actually means 7. So if you ask the rotational symmetry, just say 7. Okay, nothing, no brain. I just don't think about it. What it simply means, rotational symmetry, is that if you rotate the shape 360 degrees about its center, okay, about the center of the shape, how many times does it come back to its original shape? Okay, so if you rotate, for example, a square like this, okay, so if you rotate it, this edge will come to this spot, and then this edge will come to this spot, this edge will come to this spot. It will be as if the square is returned to its same position. So we count that as 1, and then as 2, as 3, as 4. If it's a square, you'd have guessed it, it's rotational symmetry of 4. If it's a decagon, this is a regular. Okay, regular simply means the sides have to be they are the same in terms of the size, and then in terms of the interior angles also they are the same. So they're called regular shapes, regular polygons. So for is this a decagon, the rotational symmetry would be order 10. Okay, so that's what it simply means. This question for Cambridge will be slightly different than the questions that you get in ZIMSEC, but then I'll try to explain to you and in the way that you'd understand it. What they're asking for here is to complete this shape such that when you rotate it about this part here, it returns to its position here. Okay, so that's exactly what they're asking for, nothing more. So if you want to rotate it about this part, you can make it such that if you tilt this one till it goes to the end, then this edge here actually has to come to you this part here. So you have to put this edge such that when this one returns to this position, this edge will be here. So the edge is better at a position here. Okay, so this edge will be here, such that when you rotate this shape in this direction, then this edge here will come to you to this part. Okay, let me actually see if I can do that rotation. So here it will be, if I'm putting my edge here, then I have to mirror everything else. Okay, so this one would be up to this part here. Okay, and this one would be up to this part here. So let me see if I can grab my ruler, and essentially I would be having this up to this part here. Okay, and let's see, hopefully I'll be able to demonstrate to you the concept of rotational symmetry. Okay, so this is it. So having a rotational symmetry of order 2 simply means if you rotate it to 360, it actually returns to its original shape here. So we want to see if this one here, when you rotate it 180 degrees, it gets to this spot here. Okay, so if it's order 2, it simply means that you have to rotate 180 degrees in order for you to return to the same shape. If it's order, let's say if it's order 4, then you have to rotate about 45 degrees. Okay, so let me see if I can select the outline of this shape here. Okay, and okay, so this one was here. Okay, let me see if I can rotate it with you seeing. So it was here, and we want to rotate it, so want to rotate it through 90, through 180. So it'd be like this, 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 and then it would come to this position. See what I did? I rotated about the center of this shape, so that's why it wasn't coming out okay. But then if you actually rotate about this position here, which is given, then you actually realize that it rotates to the position that we want. So it would be like this, and then it would come to this position here. And here, what I want you to take note of is this shape is exactly the same orientation as this other shape here. Okay, so that was the major key. So essentially, this is how you draw the shape for the order of symmetry 2. Okay, so what we did was a little bit of non-routine work, okay, to actually figure out exactly what we have, and also how we can manipulate what we have in order to to make it such that if you rotate it 180 degrees, which is the number that corresponds to rotation or order 2, then we'll be able to get the same shape again. This spot here would actually rotate to the spot. Okay, so this one here would rotate and then move to the spot. This one here would rotate and then move to the spot, and thereby you'd have order of symmetry 2. Okay, so yeah, that's it. So for this question, that's done. I'll catch you in the next video where we'll discuss the next set of questions. So this has been Yuba. Thanks so much for watching. Make sure you like, share, and subscribe. Yuba out.